Hi everyone. Is anyone here familiar with perf events? Anyone here use it on a regular basis? Shit. Okay. Okay, so I'm not a perf events expert. I use it on occasional basis for performance issues. I'm not going to try to be an expert. I will just share what I use it for. I will be also talking about flame graphs, EBPF and BPF trace. So about myself, I'm a DBA, or you can call me database engineer. I don't like to be called a DBA because I don't administrate stuff, I engineer stuff. So that's me. I've experience with both relational and non-relational databases. I work with MongoDB, Elasticsearch, a little bit of Redis, and other relational like MySQL and Postgres. Even though I'm an engineer, I do ops, a little bit of dev as well, but I do like to talk about databases and distributed systems, like how RAF works, how Paxos works. It's quite complicated, and I don't really understand it very well, but I still like to talk about it. I started using Postgres in 2015. That's when I joined kind of like a startup company, and I'm still using it. I try to blog regularly at this link. It's been dead for a while because of a new job, but you can check the stuff there. I'm going to tell a story of a database performance problem, not mine. If you know which company this is, please keep it to yourself for now. So this is an analytics startup in US. So their business model is very simple. If you are a customer, you install their binaries on your web servers, and every time your customers go to your website, all this information, the events, and the interaction with the website gets streamed to this startup. Real-time analytics, so you can see what your customers do, what your visitors on the website does, the interaction, and then you can get a feedback from it. And what this startup offers to the customers is they offer a real-time analytics where you can do your own graphing, you can do your own analytics, do your own roll-ups, things like that. So really, really cool. And they use partial index to speed up the queries for different customers. So it's like a SaaS product. So they use it to speed up. And in production, I think this is in 2017, they have about 10 million partial indexes so far. And problem starts to happen. As the data volume grows, they realize that their Postgres cluster CPU utilization increases. And first, as the database engineer thought, it was maybe it's just because the data volume increases, so it makes sense, CPU goes up. So they, as what people would do, they would throw a spanner at the problem and increase this EC2 instance size. And it keeps going and going up. And then they realized that ingestion from the customer sites became slower. And new events actually take hours to appear on their customer dashboard. And this is a problem because they are real-time analytics company for the customers. As a DBA or a database engineer, what would you do? PGStat, PGWatch, POA. My favorite is PG Badger. I use it all the time. PG Sentinel. Which one will you use? That will be my first thing to look at. And then, yeah, so that's what he thought. And so basically all these tools, they are like third-party or community-built kind of monitoring. It gathers stats from Postgres using PGStat activity, PGStat statements, and gather all this information. And they still couldn't figure out why. So this is where ponies come into the picture. I Googled this, so this is pretty awesome. So perf events. The unofficial mascot for perf events is ponies. And this is like, there are many, so perf events is like a tracer, system tracer, and there are many system tracer for Linux. These are all the different unofficial mascot for it. In my previous experience in my previous company, I was actually using dtrace. But dtrace isn't available on your typical Linux. It's only available on OEL, so I move over to perf events. There are others like system tab, but I wouldn't go too deep into that. So perf events, some people call it performance counters, Linux perf events, perf events. They're all the same thing. Perf events is my personal choice for system tracer. The reason is very simple. It's included in the kernel. So you don't have to do any installation, compile anything, just install it, yum install, and there you go. Linux kernel version, anyone still using 2.6? Oh, you'll be surprised. So only for Linux 3.2 and later. Linux 5 just announced, just released a few weeks back, so go and try it. So it's really useful, it's very powerful. Yeah. This is on, okay, so perf events is, I learned it from this guy called Brendan Gregg. I watch his YouTube videos, and he's like this guru in performance tuning. He used to work in Sun. After that, moved to Netflix now. Watch his videos, read his blogs and everything. So this is his official statement on what you can see from perf events. This is taken directly from his blog. So does anyone know what all this means? So no, you excluded it, go away. So, yeah, so on CPU, so is the CPU stored on I/O, memory I/O, not IOPS, but memory I/O. So as a database engineer that doesn't do low-level performance tuning on a day-to-day basis, all these are nuts to me. I don't know what all this means. But I mainly use perf events for this. Yeah, like this, okay, yeah. So this is most of the time why I use it. Whenever we need to, let's say, for example, the Postgres backend process CPU utilization is really, really high, and all you can see is Postgres backend 100%. Can't go any further, so that's why I'll use it. One main reason why we use it as well is when we do versions upgrade for both application and database. So we use it to, once we upgraded the versions, we'll do a load test. If it's not similar, we'll check the code path. So that's usually what we use it for. These are the things that you can trace with perf events. You can trace, VFS is like the layer between your file system and your application library. So if you want to trace your latency between how fast how fast your applications are writing to the file system, you trace at a VFS layer. One cool thing is you can trace PMCs. PMCs is performance metric counters. So you can trace directly at the CPU level. These are very CPU model specific. So Skylake have their own PMCs and I don't know what other Xeon, what other models there are, but it's very hardware specific. There are 3 types of perf events, counting, profiling, and trace. Counting, basically, you are interested in a particular function, and you want to trace how many times it's called. So that's usually we use it for before and after, or I use it for before and after code changes. Profiling is more useful for me. So what I do is I just trace a Postgres PID, and I can see what function is being called. Tracing, it's I'll go through that in a bit. And then once you, yeah. So these are the these are one-liners that you can use. Okay, so for me, I'm lazy, so I don't actually remember all of this. When I need to solve a problem, I go to the one-liners page and I'll start looking for it. So I just pasted this. The one thing that is quite cool that I found out recently is the TLB stands for translation look-aside buffers. So after the Spectre and Meltdown patching and everything, so I was particularly interested in the TLB miss and had to fetch it from the virtual RAM and then load it to the memory, the actual physical RAM itself. So I was quite interested in that. You can trace this call, how many times it's called. Oh, by the way, you can use all this for your applications as well, if there's any application developers here. Okay, this is, if you want to do profiling, you can trace PID, that means trace a specific Postgres backend, or can trace the entire system, that means on a Linux level. Or if you are into Docker, Kubernetes, you can also trace at the C group level itself. Perfect. Yeah, I'll skip this. Okay, so specifically for Postgres, Postgres developers are very kind. They actually, instead of, they actually expose certain trace points for us to use. They are called SDTs, or statically defined tracing. So you can have things like, you can start tracing things like what time, like when the probe, you can probe at when the transaction starts, when it aborts, when it commits, or when the checkpoint sync starts and when it's done. So you can trace the latency of it as well. So you don't have to do anything special. The thing to note is make sure you do it on a quite a recent kernel version, because I have managed to crash my own laptop while testing on a virtual box. So that is quite impressive. So make sure you test it on your staging before you do it on production. Who install Postgres via RPMs or packages? Who manually compile them? Okay, good. So you again. Yeah, so by default, when you install Postgres RPM, it's compiled without frame pointers. So when you do a perf record, you'll see a lot of question marks and weird symbols. What you can do is install the Postgres debug package, and then when you do your perf stat, you can do a call graph dwarf. So this will automatically decode those symbols, and you can see the whole thing without recompiling your Postgres again. So if you want to use the SDTs in Postgres, you have to initialize the probe first, and then you can start calling it. There's a lot of other things that you can do. It's all in the link. When you do a perf stat, this is what you see. It's not very user-friendly, is it? For most people.
This percentage is the total percentage of the CPU or the?
Yeah, on CPU. So yeah, the entire thing. So if you have like 8 CPU, it goes. So this is on. So there's like on CPU and off CPU. On CPU means that the thread inside the CPU is doing something. Off CPU means that it is not doing anything. It's waiting for maybe memory I/O. It's waiting on something or latch or whatever. So these are all on CPU. Flame graphs. This is invented by Brendan. What it does is once you collect your perf stat, you run this tool, you collapse the stat, and then then you run it, and then it will become an SVG file, which I will show later. But what is useful for is doing CPU. You can see CPU utilization at a glance. So this is a stack trace of bash, I think, or SSH. This is like, yeah. And if you use flame graphs to visualize it, it becomes like this. Difference? Pretty good, huh? Yeah, so you can use flame graphs for memory, off CPU, on CPU. You can even do differential. So like for application changes, you want to know what is your code path like before and after your code changes. So this is like perfect. Okay, so I'll do a brief explanation of flame graphs. So the y-axis, right? So sorry, the x-axis. This does not mean the time. This line does not mean the time. Basically, it's ordered alphabetically, in alphabetical order. So the x-axis does not matter. And this is just an image, but it's actually an SVG file. We can click in it and go through in more details. The colors does not matter as well. It's just random. These are the steps to generate a flame graphs. So there is a GitHub by Brendan that basically you just git clone it, and then you can run the collapse script, and then it comes out the SVG file. So now, back to the original story. The database engineer found out about this flame graphs, and he ran it. So it looks like this. And then he clicked in it. He realized that most of the time spent in the data ingestion from the sources is relation ID get relation, and relation get index predicate. So he did the next thing that any open source guy would do. Go into the source code, start looking at the function itself. And he realized that Postgres spends a lot of time fetching and parsing the partial index than actually evaluating it. So that's strange. Let me add something here first, though. The ingestion of the data from the customer's web servers to their own servers are actually every event you insert once. So in the function get relation ID get relation, it's specifically for once you evaluate the index, it will actually, by right, it's supposed to cache it. So if you do another insert in it, you don't have to re-evaluate it again. But the problem with this company is that they have thousands and thousands of events coming in. And every time there's an event, they do a fresh insert. That means the cache doesn't work. So every time they do an insert, they have to re-get the ID, the relation ID, and then cache it again. So it doesn't make sense. So what they decided to do is, instead of inserting a new event every time, they decided to batch it. And after batching it, you can see that the graph looks a lot cleaner. And most of the time spent is just evaluating the partial indexes, the exact QUAL. And this company is called HIT. I don't work for them, by the way. Just they have a public blog post about this, and just thought it's really cool to showcase about what flame graphs and perf events can do. Next thing, visualizing SQL plan using flame graphs. This is something that I read about quite recently. I thought it was really, really cool. It's not by a Postgres guy, it's by an Oracle guy. So this guy is called Tano Porter. He realized that stack traces are very, very similar to your SQL execution plan. Stack trace, you have a main function, and then you call your sub-functions, and there's time spent, which is the same as a relational execution plan. Oh, sorry. Yeah. Yeah. So it came out with a POC script that gets the execution plan and then convert it to a flame graphs format. So right now, he's doing it for Oracle execution plan. I am writing it for the Postgres version, but he wrote it in SQL, and the original stack collapse script written by Brandon is in Perl, and I have no motivation to write in Perl. So I'm going to do it in probably Python or something else, but I'm not learning Perl just to do this. Yeah. So for a typical execution plan, this is what you get. Some of you who are in the mailing list, you probably will see this as well. Very popular. People, when you ask for a execution plan optimizer, people always request for this. And I found out about this as well. I thought this was pretty cool. I didn't know about this. So it actually, you upload the execution plan. It actually tries to be smart and evaluate the thing for you. This is a flame graph of execution plan. This is not a Postgres execution plan, because I'm still working on it. But you can see that it is quite similar to your CPU stack traces. I like this quite a bit. But I find that this might not be very helpful if you have a very, very large SQL query where you do a lot of union, a lot of joins, and things like that. So this might be more helpful if you have a very, very large execution plan. Another example. So from this, you can tell that so this doesn't make sense. So you can see that most of the time spans are in the nested loops. And then if you go back, if you go up all the way, you can see that it's a nested loop semi. So this is not a Postgres thing. So you can tell that half the time, more than half the time is spent in that particular two functions. And then you can go and read the source code and then find out. Oh, not the source code, but documentation and find out why is it doing a particular scan. eBPF and BPF trace. BPF trace, yeah. Yeah. Yeah.
How can we see the SQL plan in PostgreSQL for the running queries?
Running queries.
If some query is running at the moment.
So usually what I do, there's a PG auto explain or something where it does for every, you can set and configure it. So when it takes more than 5 seconds or whatever, it will generate explain plan in the log.
Is there any other option like if we have not set the auto?
Not that I know of.
GDB. Sorry. Is that not an answer?
If it's already running and you didn't configure any kind of auto SQL plan, then probably
Today there isn't a way.
yeah.
Because in other IPMSs we can pass the split number.
I'm aware.
Yeah, we can see the SQL plan where it is stuck.
Yeah.
And that can be in Postgres will be helpful.
I will help you to fit back to the developers.
One part of that is have a universal query ID, and there is an active discussion going on, right, on having a universal query ID. I saw some links.
Yeah, I mean, there's already a query ID in PGStat statements.
But
Right.
a universal one, which is not like the PGStat statement is not like a. I mean, if you have to write another extension which uses query IDs, that it would not be same as the query ID used in PGStat statement, right?
Well, I thought the talk that was going on was
Exposing the same thing for everyone.
query ID from
Yeah.
PGStat statements.
Yeah, yeah.
Because that's actually, yeah, I mean, but that's not actually giving you the plan, right? That just gives you the query.
Yeah, and then you can have a query plan which is pointing to the query ID.
So you could potentially, but you have
You
different plans.
can kind of cache plans in kind of a, so you can have a separate view where you're caching plans based on query IDs.
Well, I mean, you could build that into PGStat statements potentially.
Yep.
If you wanted to go there, that's probably what you would do, build it into PGStat statements. But as of right now, it's not there. I've not heard of anybody actively working on it. I mean, I guess mostly because 90% of the time you can get the query itself out of PGStat statements and then, or PGStat activity,
Yeah.
and then go run explain on it and pop out comes the explain plan. I mean, that could be, it's possible you get a different explain plan if analyze ran, auto-analyze ran in between or not, but that's pretty rare.
A lot of work for. Yeah,
I'm saying it's a bad idea
it's a good idea.
for somebody to actually spend time on implementing it.
Yep.
Ultimately, if something has already been executed, let's say the query ran yesterday, and if I want to see the plan of that query,
Auto explain is your best friend. Go check it out. Like,
Auto-explain will give you that.
yeah, I use it quite often as well. So, but make sure ask your DevOps guys to do it or do it yourself. Yeah.
One of the things which is with auto-explain is it would record a query if it only crosses a certain threshold.
Yeah, log minimum duration or something like
And
that.
That means that
No, it's a different duration besides that. You
Uh,
configure it in auto-explain,
okay.
the duration.
but that also means that the query has to complete for it to get logged.
Yes.
Which
is a
means
down-
that if I have a long running query and I cannot and I kill it, I don't get the explain plan to later review that.
Chicken and egg problem. But it's the same as like normal explain as well. If no wait, actually it's
Well, that,
See, I can normally explain, I can still go ahead and get the explain plan, like I can without the analyze.
yeah without the analyze because that's because it doesn't run it.
but in that case, you can do you can also do, again, you can get the query out of PGStat activity and run explain on it.
Yeah, right.
Hmm,
Right.
True.
So basically, I can give an idea why I'm telling this, because generally what happens in our current IBM is, whenever we have a long-running query threshold 15 minutes, so we have the whole SQL and the query plan, and we send across to the application team at the very moment, and we also, as a DBA, get that. So if that is also possible in Postgres, will be helpful, because if it's
Well,
not,
if the query completes, you could pull that out of
no,
waterworks.
it's not complete, it's still running.
If it's still running, then you would have to, I mean, you could still do that, then you have to run some kind of job yourself that basically periodically connects and looks at PGStat activity.
Yeah, but if we can get a plan somewhere then by running some SQL inside the PG activity or whatever PG.
It gives you the query.
It's the same, I mean, it's 15 lines of shell script, right? I mean, if you want something that's automatic like that, it's just a matter of connect to the database, check PGStat activity, take the query, shove explain at the beginning of it, and save it and send it to your admins or your application developer.
And you can,
That's what we do, but this begins, explain, we have to run the query again to get the plan, right?
You have to run explain, you don't have to run the query. Running explain on the query does not run the query.
Okay, got it.
yeah, there's like two options. You can run it without running the query.
I'll check that, yeah.
Maybe you can write it in an extension and then open source it.
Yeah, go for it.
Next one is this. Okay. Who's old enough to know BPF? Sure. Okay, so this BPF thing is like back in the old, not really that old, but in the OpenBSD, BSD days, it was designed to use to filter packets and do analysis on packets. So some geniuses decided to extend upon it, and now it's called eBPF. This tool right here is the new sexy thing in system engineering. Like, everyone is talking about it. Yeah. So the cool thing about this is eBPF basically is just like, what it is to a kernel is like your JavaScript to HTML. So to run JavaScript, you need your V8 JavaScript engine. And this eBPF is like the V8 engine. Not the car one, but the JavaScript one. Yeah, so it is part of the kernel. It lives inside the kernel, so you can execute your user space code, but not screwing everything else up. So it is quite safe and fast. And if you're using Red Hat, it's available in 7.6. So the thing is, I tried it out when it was on 7.6 beta, and it works fine. And then I destroyed the VMs and everything. So I now installed the 7.6 official one, and it doesn't work anymore. So there's some bugs happening. I'm still trying to figure out. But it is out there. You can use in Fedora or Ubuntu or Amazon Linux. It's a yum install. It's really easy. Go try it out. So there are two ways you can use eBPF. First one is BCC. I don't know what it stands for. The other one is BPF trace. It's created by this guy, Lester Robertson, with other contributors like Brendan and a few others. I like this. I'll explain why I like this. No, actually, I'll explain it here. It has like really, really powerful one-liners. So you can do a lot of things without actually learning how to code in it. It's really cool. And it's quite similar to dtrace for Solaris back in the days. So if you have like previous dtrace script, just convert it from dtrace-n to bpf trace-n. That's it. Really easy. So you can do cool things like this. You can trace all your ext4 or XFS operations that's slower than 5 milliseconds and do it in one. Oh, these are tools written by Brendan. So you don't have to write it yourself. There's powerful one-liners. So you can do things like this. Does anybody know of any other tools that can do things like this with a one-liner or a very small shell script? Yeah. So I really like this. You can even trace read latency. So one of the previous talk that I did previously for ForceDem and last year Postgres conference was we actually talked about the MongoDB bug, and then we raised a Jira ticket, and then they say that it's our file system problem, latency is not fast enough. So my colleague Dominic wrote a dtrace script and proved that it is actually we are not bounded by latency. Every latency that writes to the VFS layer was fast. But they still throw out the ticket. But it's fine. At least we proved that it's not our problem. So that's good. So you can do powerful things like this. So summary. The the things that I would like you all to take away from this is not to be an expert in perf events or the tracing. It's like your Unix commands. You just know that there's this command called grep or man or whatever. But you don't have to know all the arguments in it. Just know that if you need to do this, if you need to do things like this, you have tools to help you. And sometimes you might need more, like the HIP example, you need things more than just PGStat activity or PG Badger, and this will be cool. One thing though, this is my personal experience. I'm not a Postgres developer, so I find that it might not be very helpful if you don't have some understanding of Postgres internal functions or system internals. But like me, you can be lazy as well. When you hit a problem, see the function name, go to GitHub, do a search, and then you can find the functions and then see what it's called. The good thing about Postgres is this. The developers it's used to start from like academic, right? So when they write the code, they actually explain the functions quite well. I've seen another company, a database open source company, of their source code. They have a function name and then they tell you what this function do. And it doesn't tell you what is this loop for, what is this hash tree for, and things like that. But Postgres source code are quite good in that sense. And it allows people that doesn't know how to write C, like myself, to understand what the code is doing. So it's actually quite cool. But for me, luckily I don't deal with performance problem every single week, unlike some others. So I'm happy to, yeah. So it's really good. That's all. Any questions? Oh, these are the links I used. Any questions? Cool. Sure?
So you've done this for Mongo
Yeah.
as well.
I'm on camera. No, I'm just joking. Yeah, come on.
I just wonder about your feelings on comparison-wise. I guess what I'm wondering really is, in looking at Postgres, have you come across anything that's wacky?
So there was a project where we were choosing MongoDB versus Postgres. That's why the reason for the previous talk. MongoDB is not ACID per se, and they don't have a lot of baggage that Postgres has, maintaining concurrency, read isolation, and things like that. It's a good thing to have. Let me take back. They don't have the goodies that Postgres has, and Postgres have read isolation and proper read isolations, and because of that, we have things to take care of, like MVCC, auto vacuum. And when we are doing the tuning on Postgres, we realized that we have to tune auto vacuum quite well, because if not, when it bites you, it will bite you really, really hard. So what we did was we did partitioning as well. So instead of having a single large table, so our project was to store 8 billion records in a single table. So we realized that we were doing like 5,000 transactions per second, doing inserts. And we realized that Postgres will go like super fast, and then there were dips, and then go like really slow, and then goes back up again. Then it's like, yeah, auto vacuum. So we tune it, and then it's good. So instead of having like high peak and low peak, we chose to have auto vacuum running all time. So it goes like quite steady, consistent. The MongoDB bug was like, it was doing like really, really high inserts. Oh no, it's not 3,000, it's 30,000 inserts. So and every 60 seconds it would drop to 0. That was in 3.2. So every 60 seconds, MongoDB will do a checkpoint flush from memory to disk. And when it flush, the IO queue just goes up and everything just stalls. So, so that's not very good, is it? So it goes 0 for like a couple of seconds and then go back up again. Yeah, in the end we chose Postgres. Yeah, I think the auto vacuum thing needs a bit of tweaking. Like the defaults are not good enough. If you have like high workload, you need to probably investigate it further. You need to have like good understanding of how it works.
Can you look at checkpoint completion target?
Yeah. So I make sure, so I can't remember how I tune it. I just make sure that auto vacuum is running at all times.
Right. Well, auto vacuum does checkpointing. Checkpointing is done by
does it not,
checkpointer process.
does it not call checkpoint?
No.
Okay.
Auto vacuum doesn't call checkpoints.
So I set it to 0.9, I think.
So that's checkpoint completion target, and
Yeah.
that's what actually will spread out the checkpoint
Yeah.
across the entire checkpoint timeout time.
I actually raised this idea to the MongoDB guys. They were like, yeah, sounds good. But yeah.
Maybe ask compliance.
Yeah, so yeah, it's good. Any other questions?
I have one subsequent question.
Yep.
Regarding this. So you have taken an example of initially on web analysis, right?
Yep.
So I assume that the data is coming from the web,
Yep.
which is in log format, log lines, web server log maybe.
Are you talking about the use case by heap or?
The first one, which is the data is coming in a log format, event format, which is analysis of real-time analysis.
Right. So that is the product of heap. That is not what gets sent over.
Okay, so I mean, whatever the data is in event format, right?
Yep.
Does it make sense to store this data in Postgres or maybe RDBMS, or does it make sense to data stored in NoSQL like MongoDB?
So what I do is, I store all this thing in syslog, send it to Elasticsearch via FileBit, and then from FileBit, you have a Kibana thing, and then just expose it to the developers and read your own execution plan. Yeah, read your own execution plan. So like DevOps style is like empowering your developers to do things, right? So stream everything to your syslog FileBit, stream it over to Kibana, Elasticsearch Kibana, and let the developers do it. They can see their.
Working on Elasticsearch, I know that's how it works. That's what I'm asking the question. Does it make sense to store this data in RDBMS, or does it make sense to store data on Elasticsearch?
So personally, Elasticsearch is my favorite NoSQL database. Like I really like it a lot. What?
Solar also. Maybe
Solar.
Don't know.
Until it gets big.
I just love Elasticsearch. So I'm the kind of guy like once I choose something, I never let go.
You will eventually.
Yeah.
If your installation gets large enough, you'll discover
For Elasticsearch.
there's limits.
Okay. I don't want to experience that.
If you ever run into him, talk to Chris Travers about it.
Okay.
He runs a couple petabytes in Postgres because Elasticsearch fell over.
That is quite big.
But that was like a single node of Elasticsearch or like a cluster of Elasticsearch?
Should be a cluster. Yeah.
In petabyte scale, it's going to be awesome. So, talk to Chris Travers. It's some interest. He's got some interesting stories. Yeah, it was in there. Yeah. Okay. Apparently, he's not the only one then. Huh?
Yeah. So that's it. Thank you.